In our basic understanding of physics, objects are made of atoms. Each atom contains subatomic particles called fermions. But what makes up these particles? Let's examine a physical string. It can vibrate at different frequencies, producing a range of different notes. Now, imagine a string a billion times smaller than an atom. When it vibrates, instead of making a sound, it manifests as a particle. One frequency produces a neutron, another a proton. What happens when these particles change or interact with each other, as in the beta decay of a neutron? Physicists use the properties of strings to model these interactions. Strings also manifest as force particles, called bosons, that produce the effects we know as gravity, electromagnetic force, and the strong and weak nuclear forces. By following the math, physicists discovered that strings occupy space, time, and an additional 6 or 7 higher dimensions. While it is difficult to imagine something that exists in 10 or 11 dimensions, this framework may be the best way to describe the behavior of forces and particles in our universe. Movement of a string in one of these extra dimensions may produce effects we can measure, such as the spin or charge of a particle. The overall energy of string's vibration determines the mass of the particle, given by Einstein's famous equation E equals mc squared. Physicists hope that their model will someday lead to a theory of everything that encompasses the 4 fundamental forces and all the known matter in the universe. Strings will then be the basic element that underlies all of physics and explains every previous theory in a new, comprehensive model.